Okay, here we have a rather complicated setup that I've thrown together over the last couple of days. A relay controlling a timer, controlling a relay, and this is messy by my standards, but basically the gist of it is I've overcomplicated this and I want to say got it wrong, but found a better way in the meantime. So what we're trying to do is utilise the 480 watts of solar panels we've got as efficiently as possible because we have a small bank. And basically what we got is a voltage sensing unit with two sense wires on the battery, a 12 volt supply and a 12 volt switched relay, switching a timer. The little orange wire is the activation for the timer, so when the voltage hits 28.5, this doesn't read as accurate as the other meters. When it hits 28.5 on here, it activates the timer, which counts down from 60 seconds, and because they're only sort of 10 amp relays and it's sort of a 13 amp load, I've put a bigger relay on to test this out. This is a 30-40 amp, yeah, it's a little bit warm. But the problem I've got is I purchased this thinking it had a timer, and I will do a separate video on this very shortly, but it doesn't have the timer function that I thought I'd get, so the timer was on this. If I have this on the battery, it chatters away, so because of the voltage sag, it will trip off and then trip on. So it's what I'm just playing about really. I've not put too much thought in it until I actually started connecting it up. But the better way to do it would be to switch half the solar panels. And this idea came to me from a YouTube comment on another video where I was talking about using these things to switch on and off a load. So this module cost me £6 and I need to get some use out of it, so here we go. Got a 12 volt supply which obviously goes to the unit, goes to the relay coil, goes to the timer, goes to the first relay. This is a bit too complicated and it's only switching on the 24 volt load. What I'm thinking of doing is, because we've got PV1 and that's going to be PV2. PV1 is on the shed roof and has 480 watt panels. PV2 has 280 watt panels. If we put a relay up top, we can switch the panels which are on the shed roof out of the circuit and direct the load whilst the battery voltage is at a set limit. If a large load is drawn from the battery, then the relay, this unit here, will drop out the bigger relay and allow the PV to come back in and charge our battery. Whilst all this is happening, PV1 will be charging at sort of a lower rate, maximum 5 amp I guess, being 280 watt panels. So that is the idea I've come up with, and as you can see down here, 12 volt supply in for the unit, 12 volt supply in through the relay. When the relay switches on through the sense wires which are attached to the battery, it will come over here and switch on the bigger relay, allowing the load to function directly off the panels. Now I assume because we've got a resistive load in here, and we'll show you that just now. The little black wires here is two of these cheap Chinese heating elements in series. I could have got the 24 volt ones, but I thought I'd just put two in series, see how it goes. And in there you can see we've got two elements just stuck on the side, a little bit steamy in there. And you can see we've hit 37.7 degrees, so it's kind of working this way. But what I want to do is experiment and put the relay or the switching device up high, take these solar panels off of here, because you can see we've got the two PV lines, PV1, PV2, and say when the battery voltage hits a threshold, these switch out of the circuit straight to the heater. That's what I'm thinking. Let me know if I've got this completely wrong, but I think that's a better idea rather than utilising three sort of electronic components for one job. This is kind of just thrown together on a Sunday afternoon, so let me know what you think. I know it's a mess, we've got time to tidy it up. Thoughts, comments, criticisms, all welcome in the comments. Stick it below, give us a like, subscribe, and I'll see you soon. I kind of left it running all day and it's done quite well actually. It's up to 61.2 there. That's not actually accurate because it only heats the top half of the water. I didn't actually show you the insides, but basically you were coming to the end of the day and the voltage is not hitting the 28.5 threshold. I did mention it wasn't as accurate as the others, but basically when it does trip and set everything off. If I turn that up, you see, you can hear that. And you've got a thermostatic thing there, and the inside is really steamy. I think I call that a success in some regards. I've got to neaten this up or listen to see what other ideas we can get from subscribers. But yeah, it's worked quite well. Let me know what you think. Please subscribe, comment, rate, and I'll see you. Oh, there we go. We've moved some water around. Let's give it a quick stir.